Hello and welcome to this video about types of bonds. In this video, we're going to look at ions and ionic bonds. We'll look at molecules and covalent bonds. We'll look at polar and nonpolar covalent bonds, and we'll look at the difference between polar and nonpolar molecules. First, let's define an ion. This is I-O-N, not L-O-N. An ion is a charged particle. That's all an ion is. So it could be a plus charge, it could be a +1, +2, +3, it could be a minus charge, a negative charge. How is an ion formed? An ion is formed because one or more electrons are transferred. So here we have lithium that has one valence electron, one in its outer shell. Here we have fluorine. It has 1, 2, 3, 4, 5, 6, 7 valence electrons. And this diagram is showing the transfer of the lithium valence electron into the outer shell of the fluorine atom. So what happens when we do that? Lithium becomes an ion. It becomes a charged particle, and because it lost an electron, it now has a +1 charge. We can write that like this. We write the lithium symbol and a superscript plus. We don't need to say +1 because it's assumed that it is +1 if there's only one +1 charge on it. Fluorine, on the other hand, has gained an electron. Remember, electrons are -1 charge each. So fluorine has now become a -1 charge. And we can write it like this, the fluoride ion. Here is another example of ions being formed. Here is a sodium atom and a chlorine atom. And sodium has one valence electron. Chlorine has 7 in its outer shell. So one of these electrons is being transferred from the sodium into the chlorine atom. And you can see that when sodium loses that electron is a -1 charge. And by losing that -1 charge, sodium then becomes a positively charged ion, +1 charge. Incidentally, we call positively charged ions cations. This is the chlorine that has now become an ion, and we call it a chloride ion with a -1 charge because it has an extra electron, contributing a -1 charge above and beyond its normal nuclear charge. So it becomes an anion, is what we call negatively charged ions. Now, obviously, there is a really strong attraction between that newly formed cation and the newly formed anion. Well, that is an ionic bond. It's the force of attraction between those opposite charges of ions. And ionic bonds are formed so that the compounds created will have 0 net charge. That's a really important concept to know, so that when you are writing these compounds, and remember, a compound is just 2 or more different kinds of elements bonded together, okay? When you are writing these compounds down, you know exactly how they're combining. And let's look at some different kinds of compounds that are forming so that you understand this idea of 0 net charge. You remember in the last frame, the sodium and the chloride ions, the sodium had a +1 charge, the chloride ion had a -1 charge. They combine in just a simple 1-to-1 ratio. But suppose we have more than one electron being transferred. Let's say we look at magnesium, and magnesium is an alkaline earth metal, and so it has 2 valence electrons, 2 in its outer shell, and so it loses 2 electrons. And when it loses 2 electrons, let's say we're putting this together with fluorine. Fluorine has 7 valence electrons. It wants to gain 1. It doesn't want 2. That's too many. It only wants 1 electron. So fluorine will simply gain 1 electron. Therefore, when magnesium reacts with fluorine, we need to have 2 fluorine atoms combining with one magnesium, because magnesium is giving up 2 electrons, and the fluorine is each of them are only gaining 1. So in this case, we'll have 1 magnesium combining with 2 fluorines to make the 2 fluoride ions. And this will be our ionic compound formed with these ionic bonds. Some atoms become stable by sharing electrons. They don't actually transfer electrons. When electrons are transferred, we have ionic bonds that are formed, but when electrons are shared, we have covalent bonding that happens. A covalent bond is just the force of attraction between atoms when they share their electrons. And one concept to note, we're going to introduce another term called a molecule, and you've heard this a lot. Molecule is just a neutral particle made up of more than one atom. Sorry about the typo there, but the atoms can be the same or different kinds of atoms. So when we say molecule, we can be talking about 2 hydrogens bonded together, or 3 oxygens bonded together. That is a molecule, but that's not a compound, because remember, a compound needs to have more than one kind of atom that are being bound together. So a covalent bond is going to form molecules or neutral particles that are sharing electrons in order to achieve their stability. Here's an example with hydrogen. We have 2 hydrogen atoms. They each have 1 electron, and they can form a covalent bond where they share equally those 2 electrons. Here are some examples of covalent bonds. Water, this molecule is an example of a covalent bond. We have hydrogen and oxygen sharing those electrons. Methane is an example of covalent bonds between the hydrogen and the carbon. Carbon has 4 valence electrons, and it's right in the middle. It doesn't really want to gain 4 more. It doesn't want to lose 4. It ends up forming really nice covalent bonds by sharing, in this case with hydrogen. We can also have double bonds or triple bonds being formed with covalent bonds. Here's an example with oxygen. You can see that each oxygen has 6 valence electrons, and when they combine, they can share, and it forms this double bond. In this kind of structure, each of these lines represents 2 electrons. And in this case, the oxygens are sharing 2 electrons here and 2 electrons here, 4 total. So it's a double bond. The nitrogens in this case are forming a triple bond because they're sharing 6 electrons, or 3 pairs. Covalent bonds can be polar or nonpolar. And you have seen this word so many times. Polar means just different-sided or unequal sharing. If you think about the North Pole and the South Pole, they're at opposite ends. If something's polar opposite, it's completely different. So in a polar covalent bond, we have unequal sharing of the electrons because not everything shares alike. Oxygen, they're identical molecules. They will have very equal sharing. We will call a bond with 2 identical types of elements nonpolar covalent because their sharing will be very much equal. But if we look at the case of, say, hydrochloric acid or hydrogen chloride, chlorine really has a stronger pull of those electrons. It wants the electrons more than hydrogen wants them. And so we indicated that this means slightly negative. It's the Greek lowercase letter, and we just call that slightly negative. This is slightly positive. It doesn't have a full positive and negative charge, but they're pulling, the chlorine is pulling a little bit more on those electrons, so it has a slight negative charge, and we call it polar covalent because it's an unequal sharing of that bond of those electrons. We can also talk about molecules being polar or nonpolar, not just their bonds, but the whole entire molecule itself. If we have an entire molecule that is polar, it means that unequal sharing from the individual bonds has resulted in an end or a side of the molecule that is slightly positive and a side that might be slightly negative. So when we look at water, everyone knows water is polar. It has a side to it. It's uneven. And in this case, the oxygen is the one that hogs the electrons a little bit more, so it's slightly negative. And then these sides where we have the hydrogens, they are slightly positive because those that unequal sharing in the bond in this these two polar covalent bonds is pulling the electron charge a little bit away from those hydrogens. What about these other molecules right here? Pause the video and see if you can tell if they are polar molecules or non-polar molecules. They all have polar bonds in them, but is the molecule polar or non-polar? Here are the answers. We have a polar molecule, obviously. Here, this is slightly negative, slightly positive. Here's a little way to describe the way the electrons are being pulled. They're being pulled in this direction so that this end ends up being slightly positive. This molecule, even though it has all of these polar covalent bonds, you can see that, 4 of them, the molecule itself is non-polar. Because of the geometry of the molecule, it's evenly being pulled in all these different directions, and there isn't a side to the molecule. So the molecule itself is nonpolar. This one as well, because they are being pulled straight apart at equal angles from each other, the molecule itself is not sided. However, this one is polar because these hydrogens are bent down away a little bit from the nitrogen. So this would be a polar molecule because this has a little bit more slightly negative value, and this side would be slightly negative, whereas the side down here would be slightly positive. This would also obviously be a polar molecule. We have the chlorine that is much more strongly attracting the electrons in one particular direction. Advanced ideas. Find out what an induced dipole is. Sketch a diagram to illustrate an example of an induced dipole. Research electronegativity scale developed by Linus Pauling. What is that? Can you relate that to the information of covalent, polar covalent, and ionic bonds? Research the work of American chemist Gilbert N. Lewis. Write a short paragraph about his contribution to electron dot diagrams. And I look forward to seeing what you come up with in class.